Greetings, my name is Shazina and I am from Group 6. So in this project, we are going to discuss about the design and the thermal analysis of the piston head. So moving on to the abstract. So the engine piston is the most important component in the IC engine. As the car cannot survive without an engine, the engine cannot carry out its function without pistons. While it is generating power for the engine, high thermal load and thermal stresses are acting on the piston, thus reducing its lifetime. In order for the engine to operate at its best, it is important to keep the piston in good condition. Most often, failures of pistons are contributed from thermal conditions. So in this project, piston head is created using SolidWorks, and then using ANSYS, structural and thermal analysis of the piston head is carried out. 1.1 Introduction. So in 1826, Samuel Morley was the first who secured the patent for internal combustion piston engine, which the ignition of the fuel leads to the expansion of the cylinder. Not until 1858, the first three-wheel wagon fitted with internal combustion engine was produced and can travel up to 50 miles. So piston is the core in many different kinds of engine, mainly in the automotive sector, pumps, machineries, molding, and in hydraulic system. It slides back and forth in the cylinder by the forces produced during the combustion process. Piston consists of many different parts, such as the piston crown, piston head, and many more. The piston head, which is located at the top, are subjected to severe heat and force during the normal engine operation. There are four objectives of this project. So the first one is to develop structural analysis in the piston. The second one is to perform finite element analysis on the piston. Third one is to analyze stress distribution in various parts of the piston. And lastly is to investigate and analyze thermal stress and mechanical stress distribution of piston at real engine operating condition. Now we are going to discuss about our problem statement. So in order for the piston to work perfectly without any failure, analysis have to be carried out to identify the thermal stress for the piston head, whether it may lead to mechanical failure or contribute to power loss. SolidWorks have been used to design the piston head. Then using ANSYS, thermal analysis on the piston head is carried out. Chapter 2. Design Consideration and Properties. In 2.1, we have the piston mold design. So in the left side is the schematic diagram of the piston, and then on the right side we have the piston connecting rod along with the rod cap. Next, moving on to 2.2, which is the design consideration for piston head. In our analysis, we mainly focus on the piston head without any piston rings and connecting rod attached to the piston. There are several things that needed to be considered during designing the piston head. So the first one is the ability to withstand high pressure in the cylinder, mainly during the compression and power stroke. Second is the ability to dissipate heat generated quickly to the cylinder wall. And lastly is the simplification of geometry. It is assumed that the top of the piston head is flat circular plate of uniform thickness, fixed at the outer edges and subjected to a uniform distributed load due to the gas pressure over the entire cross section. In 2.3, we are going to discuss about several functions of the piston. So firstly, it seals the combustion chamber. Second, it dissipates heat generated during the expansion stroke from the combustion chamber to the cylinder wall. Third, it provides space for the piston ring, which function to prevent oil leakage and maintain compression. As we all know, there are two types of piston ring, which is the compression ring and the oil ring. Fourth, it supports gas exchanges. And lastly, it moves in a reciprocating motion, which leads to intake, compression, power, and exhaust stroke. 2.4. Design considerations for a piston. There are many things that needed to be considered when designing a piston. So the first one, it should be able to dissipate heat quickly to the cylinder wall. Secondly, it should be able to withstand high gas pressure and inertia force. Thirdly, it should have minimum mass to minimize inertia forces. Fourthly, it should form an effective gas and oil sealing on the cylinder with the help of compression and oil ring. Fifth, it should accommodate sufficient bearing area to prevent undue wear. Sixth, it should be able to reciprocate at high speed without any noise. 7. It should have a rigid construction to withstand thermal and mechanical distortion. And lastly, it should have enough support for the piston pin. 2.5. Force acting on piston. There are 6 forces that acting on a piston. The first one is thermal load. Second is the inertia force. Third is crank pin friction and forces. Fourth is sidewall friction and force. Fifth is due to power stroke. And lastly is due to expansion stroke. 2.6 Material for piston. So pistons are commonly made out from cast aluminum alloy. Other several materials that are used for engine pistons are cast iron, forged steel, and forged aluminum alloy. So for our piston, we use cast iron, which has carbon content ranging from 1.8 to 4 weight%, and silicon from 1 to 3 weight%. There are several characteristics of cast iron, such as it is hard, brittle, non-malleable, fusible, and also excellent in compression. There are several advantages of cast iron over aluminum. Firstly, it has a higher wear strength. Secondly, it has a higher strength. As the strength of aluminum alloy piston rapidly decreases as the temperature increases. Next, it also has a low coefficient thermal expansion, thus less clearance between the cylinder wall and the piston ring. So to summarize, cast iron pistons are best used in moderately rated engine with piston speed below 6 meters per second. Meanwhile, aluminum alloy is used for highly rated engine for piston speed more than 6 meters per second. In 2.7, we are going to discuss about the engine, or specifically, the vehicle. So the piston that we have designed meet the requirements for the piston that are used for the 4G54 engine. So it is a 2.6 liter 8-valve SOHC engine that is used in the rear-wheel drive and all-wheel drive. It produces 114 horsepower at 500 RPM and has a torque of 198 Newton meter at 3000 RPM. It also has a compression ratio of 8.8 to 1. Mitsubishi Pajero are fitted with this engine, which is the 4G54 engine.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faisal bin Hashim. My metric number is MH18003. Today, I want to present about methodology part of our project. In order to create a piston that can work perfectly, we need to make a few tests to make sure that we can have a perfect design of piston that can work without any failure. In our case, we have done 2 tests to designing the piston with 2 different software. The reason that we use 2 different software to test our piston design is to make sure that we can get the accurate design in different angle of view of the piston design that can work like we consider for our engine. The software we use to draw is SolidWorks. We use SolidWorks to draft the piston model, to draw the 3D model of our piston. And SolidWorks also we use to get the accurate angle of view of the piston. And for the analysis of the model, we use ANIS. ANIS is very good software to test the movement of the piston, simulate the piston model structure, analyzing strength, toughness, elasticity of the piston model. After we make some research, we have found the information that we need to consider in order to make sure we can make a good design for our piston. After we make some analysis with these two software, we can get the accurate model of the piston for our project. Okay, that's all from me. Thank you.
Hello, my name is Dayabin Sipaan, metric ID MH18035, and I will be presenting for the result and discussion for our piston head analysis. In this chapter, we will discuss the result that obtained from the piston head that has been analyzed using the ANIS software, and also we have performed theoretical calculation by using the kinematic equation, and this part will be explained by the other members of our group. We have plotted the graph for the acceleration, cohesion, and velocity versus spring angle using the Skylab software to see the behavior of the piston of the vehicle. The pressure and triangle degree also has been plotted to see the maximum pressure during the combustion process. So this is the ANIS software analysis, which divided into two parts for the thermal analysis and static analysis. In thermal analysis, we do this analysis to see and analyze the heat projection during the combustion process. And also, we have assumed that the starting temperature before the engine being started up and during the combustion process is 22 degrees Celsius and 2000 degrees Celsius. And we use stagnant water for the coolant medium. For the static analysis, we perform this analysis to analyze the deformation of the piston head when a pressure is applied on it. And the pressure that we set is 9 megapascal. This is the result for the thermal analysis. As we can see from the picture, that the top surface of the piston head is the most affected area to the high temperature during the combustion process. And the side face of the piston head is less affected because of the gap between the cylinder wall that prevent the heat during combustion process to hit the side face directly. And this is the graph of temperature that we obtained from the thermal analysis. And as we can see here, that the data is rapidly increased until it reached the maximum heat applied. And for the heat flux projection during the combustion process, the heat flux projection concentrated at the top surface of the piston head. And the affected area of the heat flux is at the edge point of the piston head top surface. And the graph that been extracted from the heat flux analysis is, it shows that the maximum point of 46.61 watt per millimeter square total heat flux that generated during the combustion process. And this value is increased directly proportional to the time consumed during the combustion process. And for the reaction probe, we can see here that it is mostly affected the top surface of the piston head. And this situation occurs because of the top surface is the only part that receives and heat directly by the combustion flame during the power stroke.
Now, we're gonna see about the static analysis. Static analysis is to determine the most steady part in the piston. So we're gonna use the pressure of 9 megapascal. For the first we're gonna test is the deformation. As the figure shown in the screen now, the middle of the top surface, the red part have the most opportunities to cause deformation. It is because when the piston is running, the part have the most impact from the other part of the piston. It's because that part is going to hit the surface of the cylinder every time it spins. Now we're gonna see about the strain analysis. It was same as the deformation. The middle part of the piston, which is shown in the screen, the yellow part will go to the strain analysis, because the part will have the change in the length and the dimension, because it's more impact this compared to the other side of the pistons.
Okay, my name is Muhammad Farin bin Azman and my metric number is MH18037. Okay, I will explain about the kinematic theory for our project. The definition of kinematic is the motion of point body without consideration of the cause of motion. For the kinematic, we are using the diagram linkage of geometry and formula instantaneous piston position, linear velocity, acceleration, connecting root angular velocity and connecting root angular acceleration to calculate the kinematic of piston. Okay, for the kinematic calculation of piston, we have assumed the value of crank radius is 300 mm, connecting root length is 1300 mm, and crank angle is 75 degree. First, we need find the crankshaft angular speed. Before we calculate the velocity of the piston, we need using the formula for find the value of n, which is connecting root length divide crank radius. Then we continue. The next calculation is instantaneous piston position, linear velocity, acceleration, connecting root angular velocity, and the lastly formula is the connecting root angular acceleration. After we calculate, we get the result for the instantaneous piston position is 254.6511 mm. For the linear velocity is 24.3017 meter per second. For the acceleration is 2277.7471 meter per second square. For the connecting root angular velocity is 79.9819 radian per second. Lastly is connecting root angular acceleration is we get 1564.4518 radian per second square. Okay, that is all calculation for the kinematic of piston.
So here I will continue the presentation for the graph of acceleration, position, and velocity versus the crank angle degree. And we have specified to use the stroke for the piston is 90 mm, the crank radius is 300 mm, and the connecting rod length is 160.61 mm. This is the graph for the acceleration versus crank angle degree. And from the graph, we know that the acceleration occurs during the piston movement from the bottom dead center until 3/4 of the stroke before the top dead center. is occurred during the compression stroke. And during the compression stroke, the piston head experienced a high pressure on the top surface of the piston. And this is shown during the Ennis analysis for the total deformation. For the velocity versus strength angle degree, the movement of the piston when it completes a cycle of a normal four-stroke engine, every time the piston reaches either the bottom dead center or top dead center, the velocity is equals to 0 millimeter per radian. And for the last analysis using the Skylab software is the position versus the strength angle degree. And based on the graph of the position, we can determine that the position of the piston at bottom dead center is at the lowest point of the engine stroke and at the lowest pressure of the combustion chamber. And when the piston reaches the top dead center, the pressure rises and the piston is at its highest point of the engine stroke. And every time it hits 180 degrees of the top dead center, the piston head will be subjected into high pressure and high temperature due to the compression stroke and also power stroke. So here is the graph of pressure versus the strength angle degree that we have been done using the program that have been given to us. And this graph of pressure versus strength angle degree show at 18 degree of current angle, the maximum pressure is 80.93 atmospheric pressure. And at this point, the piston head top surface induces massive amount of pressure that occur due to the high temperature and high pressure during power stroke of the engine. And this condition causes the piston head to experience high stress and strain force that lead the piston head deformation. And the deformation details are shown during the static analysis. So for the conclusion part, what we get from our project is, before we start our project, we have encountered some difficult issue in determining what type of engine and piston that we want to use. And in the end, we have solved this issue and we choose the 4G54 engine that run the Mitsubishi Pajero. And what we learned throughout our project is we learned to use the SolidWorks software to sketch for our piston head. And we learned to use the Ennis software to run our piston head analysis. Use the Skylab to run our graph and piston behavior analysis. And lastly, we perform the program that have been given to us in Excel format to run the analysis regarding the piston behavior during the engine running process. So to conclude our result from this project, we find out that our piston may have some serious issue about its toughness during the power stroke process, where it has a weak point that might affect the piston head strength and leads to piston rupture. So assume that the piston design that we selected is not practical to be used for a long period of time. That's all from us. Thank you.